How do you make a game like Garden 2 and Roblox Studio? Well, last time we've been taking a look at how we can implement a plant mechanic like this one. So now I guess it only makes sense to now focus on create this kind of growth mechanic, so your players have this kind of visual cue when it comes to a plant's progress. So let's switch right into Roblox Studio. So we're inside Roblox Studio now, and this is essentially our experience so far. And if you want to deep dive into this, I will be obviously linking the entire playlist at the top right as always. But I think this one will be helpful for you either way. Maybe as a quick recap, the way we implemented this is by connecting to the tools and build an activated event, shoot a raycast, and then fire a server event, which will then just duplicate a template we got, parent it to the player's plot, and set its relative position, like relative to the player's floor. This is essentially where our template is sitting. But now if we want to animate this essentially, and we want to set the growth time, or maturity time I guess, there are two ways to animate this. Like we can just scale this entire model dynamically, we can also have it kind of like expand naturally, and this time we will be focusing on the former one, since it is the same way I did it in my Garden 2 like premium framework, and also the respective plot system you can find as a modular piece in the description. But I also plan to touch on the latter one real quick at some point in this video. So if we want to find out whether, for instance, 50%, like whether a plant's growth progress is, for instance, 50%, we will have to memorize the growth time, and then from that we can also define the completion time, like the growth time, like plant time for instance, plus 10 seconds. So in my case, and we can do this differently, this is again the code snippet we execute, or we run whenever we plant a new crop. We can now use attributes, for instance, to save this very time. And you can also go with os.time here, but you will have to go with either one like across your entire project, since this one has a slightly different formatting. And now you can see every time we plant a new plant or a seed, it shows up as a new attribute below here. And for this episode we won't be saving this persistently, but we may do it at some point in the future. Like I do in my framework I was just showing you. We got the plant time, and we also implicitly got the harvest time, like the completion time. And now a very simple way to update the plant's progress is to calculate their percentage each second, for instance. So this code snippet will then run the code that is between those two lines every second, or whatever you prefer. You can also, run this in parallel, but then you need to, if not like this, you need to make sure not to put any code below this. So let's give this a try. There you go, 1 second, 1 second, 1 second, and so on. And now what we can do if we want to scale this entire model, like dynamically, is retrieve the plant time we just set, calculate the completion time, and the percentage progress we're currently sitting at. So we want to do this for all plants. In my case, we want to go over each plot, like each element in here, and then go over each plant, so iterate through those folders contents. And yes, obviously there's more performant ways to do this, but I still think this might be a good compromise, between simplicity and performance. So this is how we can calculate the relative progress then. We get access to the plant time, add for instance 10 seconds to it. Of course you can also kind of discriminate here and go with a separate value for each type of plant. For instance, in my premium framework I have this attribute here in the data table, but we need to use tick here to keep it uniform. And now for 2 seconds in, for instance, the current time minus the plant time will be 2, but we also divide by the total time here. So instead of ending up with 2 seconds, because we're 2 seconds in, we end up with 20% in this case. And let's assume the user waits for 2 hours. Then we don't want to end up with 2 million% as scale. So this is why we clamp it, so we can make sure it is between, in my case, 1/100 and 1, including the 2. I guess you can also go with epsilon here. This is just so that once we scale in a minute, we don't end up with any errors, because we can't make our object infinitely small. Let's have a look whether or not this works so far. Okay, looking good so far. Let's see, is it wishful thinking? Perfect. And now if we want to set the scale multiple times in a row, we will have to kind of have a baseline, like register a default value. So when we say 20% and then 40%, it is 20% of the original size and 40% of the original size. Otherwise, if we take 20% of the original size and then we take 40% of the new size, like 40% of those 20%, it will get even smaller. So that's why. And here's the code snippet I use for this. So as you can see, it supports both base parts as well as special meshes. And since it is meant to be for models, it accounts for all of their descendants. So not just the direct children, but also like nested children. And then for each of those descendants, we use an attribute again to register the original size. And base parts already have size values like this by default. We essentially just move it from here to there. So let's make sure to call this whenever planting a new plant, or a new seed I should say. And this just means we want to run this dedicated code snippet having this name we just set. Just a clean way of coding, and especially reusing code. And this is our final scale model function then. And no worries, this is way simpler than it looks as always. So we go over all of its descendants again, and we retrieve the attribute like the original size we set up here, and apply the scale. So we don't apply it to object.scale, but instead to this attribute. And then we set it here. And the reason why we do this is in order to preserve like the original offset. Since, for instance, if you got a tree and you set all of its parts to, I don't know, 10 times the size, the apples, for instance, might get hidden inside the leaves. So this is why we restore the relative positions using the pivot we briefly store up here. And now we can use this now and in the future. Like that's the beauty of creating functions like this. And just pass our relative progress right in here. So I guess now let's see if we messed up anything. Yeah, that's awesome. But I have this kind of deja vu right now. As you just saw, the quote-unquote worst case is essentially if the remaining time, like until the next update, is I guess 1 second minus epsilon, then we will have to wait roughly 1 second until this gets applied for the first time. The crop might kind of start big and then get small and then become big again. So let's make sure to set it to a very small value at the start here. And with some programming languages, this is also called EPS or epsilon or something, or small, but so far I wasn't able to find anything in here. Maybe somewhere else. So let's find out whether we were able to fix it. Yeah, I guess that's better now. Perfect. And by the way, I will also be linking this entire Roblox file in the video's description for you to download. But my experience tells me you might be better off understanding all of this nonetheless. Like at least give it a try. And maybe another thing I wanted to share with you real quick. So let's say you want to go with the other approach I was outlining earlier, or even combine both of those. One way of doing this would be, for example, to sort of mark the ones you want to show up at their respective time. So for instance, you could set this to 1, like when it comes to its name, this to 2, this to 3, and so on. And then we can, for instance, store the current progress like so, and hide those by default, like either through code or directly inside Studio, like by setting the transparency to 1, or if applicable, setting can collide to false. And then in here, instead of scaling the model, you can keep it on nonetheless, obviously. We can just get its progress and increase it by 1, and then override it using set attribute. And then again, this is just meant to be for visualization. We can see if there's an object called whatever this is, like called 1 or called 2 or whatever. And if so, we set its transparency back to 0. So let's dare to have another look. Exactly. So yeah, up to you which of those you prefer essentially. I feel like people just love if I go over various ways to do things like this. And I think for now I want to put this in again, so you can decide for yourself which of those you would like to use in case you want to use this as a baseline, like in the description. And yeah, this is how you can implement a Grow Garden 2 like growth process inside your Roblox experience. And next time we will be having a look at how we can harvest those then. So until then, feel free to let me know if you need help with any of this. And yeah, enjoy your carrots or whatever.